Hello everyone, this is me Debosmita Sarkar. Today we are going to talk about structure of an atom. So let's begin. Introduction to structure of an atom. Essentially, the structure of an atom comprises protons, neutrons and electrons. These basic components provide the mass and charge of the atoms. The nucleus comprises proton and neutron with the electron orbiting around that. Atoms are the building blocks of matter. It is the smallest unit of matter that is composed of three subatomic particles, the proton, the neutron and the electron. Atoms is indivisible and it came from the Latin word atomos. Cathode ray experiment. J. Thomson discovered the existence of electrons. He did this using a cathode ray tube, which is a vacuum sealed tube with a cathode and anode on one end that created a beam of electrons traveling towards the other end of the tube. The air inside the chamber is subjected to high voltage and electricity flows through the air from the negative electrode to the positive electrode. The characteristics of cathode rays means electrons do not depend upon the material of electrons and the nature of the gas present in the cathode ray tube. The experiment showed that the atom was not a simple indivisible particle and contained at least one subatomic particle, the electron. This is the apparatus of the experiment. Electrons are the negatively charged subatomic particles of an atom. The mass of an electron is considered to be negligible and its charge is -1. The symbol for an electron is this. Electrons are extremely small. They are found outside the nucleus. Thomson's model of an atom. According to Thomson, first, an atom consists of a positively charged sphere and the electrons are embedded in it. And the second is the negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. The first model of an atom to be put forward and taken into the consideration. He proposed a model of the atom to be similar to that of a Christmas pudding or watermelon. The red edible part of the watermelon is compared with the positive charge in the atom. The black seeds in the watermelon are compared with the electrons which are embedded on it. Radioactivity. Radioactivity is the term for the process by which an unstable nucleus of an atom loses energy by giving out particles. It does so by giving out particles such as alpha and beta particles. The process is spontaneous and atom is unstable if the nucleus has an imbalance, meaning a difference in the protons and neutrons. This is the diagram for the radioactivity. Rutherford's experiment and observations. In this experiment, fast-moving alpha particles were made to fall on a thin gold foil. His observations were a major fraction of the alpha particles bombarded towards the gold sheet pass through it without any deflection, and hence most of the space in an atom is empty. Some of the alpha particles were deflected by the gold sheet by very small angles, and hence the positive charge in an atom is not uniformly distributed. The positive charge in an atom is concentrated in a very small volume. Very few of the alpha particles were deflected back, that is, only a few alpha particles had nearly 180 of deflection. So the volume occupied by the positively charged particles in an atom is very small as compared to the total volume of an atom. Rutherford's model of an atom. Rutherford concluded the model of the atom from the alpha particle scattering experiment as there is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. The electrons revolve around the nucleus in well-defined orbits. The size of the nucleus is very small as compared to the size of the atom. This is the Rutherford's model of atoms. The red one, the red one and the black one full consist of a nucleus. The black ones are the neutrons and the red ones are protons, and the black lines are the electron orbits and the blue balls are electrons. Drawbacks of Rutherford's model. He explained that the electrons in an atom revolve around the nucleus in a well-defined orbit. Particles in a circular orbit would experience acceleration. Thus, the revolving electron would lose energy and finally fall into the nucleus. But this cannot take place as the atom would be unstable and matter would not exist in the form we know. Be more curious. The milkman's oil drop experiment was an experiment performed by Robert A. Millikan and Harvey Fletcher in 1909 to measure the charge of an electron. In the experiment, Millikan allowed charged tiny oil droplets to pass through a hole into an electric field. By varying the strength of an electric field, the charge of an oil droplet was calculated, which always came as an integral value of E. The conclusion of this is that the charge is said to be quantized, that is, the charge on any particle will always be an integral multiple of which E, which is 1.6 into 10 minus 19, which is 3, minus 3 actually. Properties of electrons, protons and neutrons. Particle electron. Charge on the particle is minus 1 unit. Mass of the particle is 9.11 into 10 to the power minus 31 kg. Symbol is this, and location in the atom is outside the nucleus. Proton plus 1 unit, 1.673 into 10 to the power minus 27 kg. Symbol is this, and it is in the nucleus, and neutron is also in the nucleus, and it has no charge, and the mass is 1.675 into 10 to the power minus 27. Bohr's model of an atom. Bohr came up with this postulate to overcome the objection raised against Rutherford's model. Electrons revolve around the nucleus in stable orbits without emission of radiant energy. Each orbit has a definite energy and is called an energy shell or energy level. An orbit or energy level is disintegrated as KLMN shells. When the electron is in the lowest energy level, it is said to be in the ground state. An electron emits or absorbs energy when it jumps from one orbit to another energy level to another. When it jumps from a higher energy level to lower energy level, it emits energy while it absorbs energy when it jumps from lower energy level to higher energy level. See, this is the diagram. The green is K shell, blue is L shell, black is M, and N is the pink shell. And the pink plus is positively charged nucleus. Orbits are energy shells surrounding the nucleus in which electrons revolve. Electron distribution in different orbits. The distribution was suggested by Bohr and Bury. The maximum number of electrons present in a shell is given by the formula 2n square, where n is the orbit number, energy level, index 1, 2, 3 and 4 and so on. The maximum number of electrons in different shells are as follows. The first orbit will have 2 into 12 is equals to 2. The second orbit will have 2 into 2 is equals to 8. The third orbit will have 2 into 32 is equals to 18. Fourth orbit 32 and so on. The shells are always filled in a stepwise manner from the lower to higher energy level. The electrons are not filled in the next shell unless previous shells are filled. Valency are the electrons present in the outermost shell of an atom are known as the valence electrons. The combining capacity of the atom, or the tendency to react and form molecules with atoms of the same or different element, is known as the valency of the element. Atoms of element having a completely filled outermost shell show little chemical activity. Their combining capacity or valence is 0. For example, we know that the number of electrons in the outermost shell of hydrogen is 1, and in magnesium it is 2. Therefore, the valence of hydrogen is 1, and as it can easily lose 1 electron and become stable. On the other hand, that of magnesium is 2, as it can lose 2 electrons easily and also attain stability. Atomic number. The number of protons found in the nucleus of an atom is termed as the atomic number. It is denoted by the letter Z. Mass number and representation of an atom. Protons and neutrons are present in the nucleus, so the mass number is the total of these protons and neutrons. This is the simple way to give us all the information we need that about the subatomic makeup of an atom is via chemical or isotopic notation. Here 24 is the mass number, means proton plus neutron. Mg is the symbol of element, means the name of the element, and 12 is the atomic number. Isotopes and isobars. Isotopes are defined as atoms of the same element having the same atomic number of protons, but different mass numbers, number of protons plus neutrons. For example, in the case of hydrogen, we have hydrogen mass number is 1. Then in hydrogen 2 deuterium mass number is 2, and hydrogen tritium mass number is 3. Atoms of different elements with different atomic numbers which have the same mass numbers are known as isobars. For example, calcium and argon both have the same mass number 40. So 20 calcium 40 and 18 argon 40. Calculation of mass numbers for isotopic elements. When an element has an isotope, the mass number can be calculated by the different proportions it existed. For example, take 98% of carbon in 12 unified mass and 2% carbon in 13 unified mass. This does not mean that any carbon atoms exist with a mass number of 12.02 unified mass. If you take a certain amount of carbon, it will contain both isotopes of carbon, and the average mass is 12.02 unified mass. Now we will see some frequently asked questions. First is, what are the features of Thomas atomic model? J.J. Thomas experiments with cathode ray tube showed that all atoms contain tiny negatively charged subatomic particles or electrons. Thomson proposed the plum pudding model of the atom and also the watermelon. Who was Ernest Rutherford? Ernest Rutherford was a New Zealand physicist who came to be known as the father of nuclear physics. And what did Niels Bohr discover? The Niels Bohr discovered a theory for the hydrogen atom based on quantum theory that some physical quantities they only take discrete values. So with this we came to the end. Thank you. Please do like, share and subscribe to my channel. Don't forget to comment in the comment section below. Bye bye. Stay home and stay safe.